humans and animals utilise similar principles to develop their skills and behaviour. That is, both humans and animals benefit from classical conditioning and operant conditioning. Furthermore, humans and many animals also benefit from observational or social learning. So what distinguishes human and animals? Why do humans seem to learn more rapidly and certainly more extensively than animals on many tasks? One answer is that humans, but not animals, can also utilise another principle to develop their behaviour. And this principle is often called rule-based learning. And the reason that only humans can apply rule-based learning is that animals have not developed advanced capabilities in language. Now, you might dispute the notion that animals have not developed advanced capabilities in language. After all, animals certainly seem to communicate. They might, for example, emit sounds or initiate some other behaviour to indicate to peers that some prey or predator is nearby. Or they might generate a sound or enact some behaviour to indicate they're ready to mate, and so forth. For example, if dogs exhibit a play face, with their mouth open and tongue out, they merely want to play. So their next act of aggression towards other dogs will be friendly rather than hostile. Even honeybees communicate using what's called the Waggle dance. In particular, they often repeat a figure 8 pattern similar to the sort of pattern in this slide. The angle of this figure indicates the direction of food. If the figure is directed towards the upper left, for example, the source of food is towards the upper left as well. And the number of times they repeat this pattern indicates the distance. If they repeat this pattern only a few times, the food is close. If they repeat this pattern many times, the food is farther away. Now, at first glance, this behaviour of bees seems like a form of communication. That is, other bees sometimes, but not always, respond to this pattern. If one bee implies the food is, say, 10 metres to the north, other bees will tend to fly 10 metres to the north. Yet, in some instances, perhaps they would have flown to this spot anyway. That is, perhaps the other bees merely sensed or smelled this food. And other counts can also explain the behaviour of these bees. In other words, whether this dance really constitutes communication is still actually contentious. But regardless, animals do seem to communicate to one another. That is, they emit sounds or initiate behaviours that convey information to one another. But is this communication tantamount to language? In a moment, I'll show you that animal communication, although sometimes remarkable, is probably not the same as human language and does not entail some of the helpful features of human language. So what constitutes human language? Is talking, for example, the defining feature of human language? And if so, some animals certainly demonstrate human language. That is, for example, a few parrots can talk. Nevertheless, few animals can talk. Even chimps, although able to learn to communicate, cannot speak orally, although they can learn to emit a few sounds by manipulating their mouth with their hand. Yet, of course, talking cannot be the defining feature of human language. After all, sign language does not entail talking, but seems intuitively to be a form of language. By the way, can you guess this sequence of 4 signs? Focus on the third sign. Yes, the signs are A, B, C, and D. So, what are the defining features of language? Well, before I answer this question, I should first emphasise that some animals can develop remarkable skills that resemble language. For example, one researcher utilised operant conditioning to teach a gorilla, named Coco, some American Sign Language. And Coco learned to emit 1,000 or so signs and also to understand about 2,000 words of spoken English. To illustrate, when told her cat had died, she signed the words that represent frown, cry, and frown, an appropriate response in this circumstance. And Coco even learnt to invent sign language. Coco seemed to combine the signs for finger and bracelet to convey a ring. Now, admittedly, we don't really know that Coco was communicating. When the trainer looks upset, Coco might have learned to represent frown, cry, frown, because the trainer might have inadvertently reinforced this behaviour with laughter in the past. When Coco invented the sign for a wing, we don't actually know that Coco was actually thinking about a ring at the time. In other words, the behaviours might not quite represent our definition of language, but instead emanate from operant conditioning. But besides primates, some birds can also develop remarkable skills that resemble language. For example, Irene Pepperberg utilised operant conditioning to train an African grey parrot called Alex. In essence, to train the parrot, an assistant would model a specific behaviour, such as repeat a word, and then Irene would then direct attention to this assistant. And hence, Alex would perceive this other person, this assistant, as a rival for the trainer's attention, and thus enact the behaviour too. And through this process, over time, Alex developed a remarkable set of behaviours and vocabulary. For example, if asked what shape or colour is a specific object, Alex could articulate the answer. If asked whether one object is bigger or smaller than another object, Alex would correctly say bigger. Alex even learned to create new words by combining other words. For example, Alex invented the word bannery, seeming a blend of cherry and banana. Now, but despite these sophisticated skills, the question still remains as to whether or not animals utilise language. To answer this question, we need to delineate the defining features of language. And researchers have identified 16 or so features of language, although these 16 features can be reduced to 4 main clusters. Interestingly, as we'll show, no animal definitively exhibits all these features. This finding, admittedly, is unsurprising because these 16 features were developed to define human language. So the prospect that animals could also demonstrate these features was also going to be unlikely. The first feature, the first cluster of features, is called reference. In particular, we can refer to objects that are not in our vicinity, that is, objects we can't see or sense, such as, say, black holes. And this capacity is called displacement. And to refer to these objects, we can use sounds or symbols that are arbitrarily related to the meaning. So the word black hole could have been any other sound, such as shibabuga. And the sound of this word is actually unrelated to the meaning of this word. Now, admittedly, in sign language and even spoken language, some exceptions are observed. For example, for these 4 concepts, the sound of the word is related to the meaning of the word in some way. Can you guess these words? Well, the answers are bar, hiccup, bang, and splash. And in each instance, the sound of this word mirrors the sound the word represents. So bar sounds like the sound a sheep emits, hiccup sounds like hiccup, bang sounds like a bang, and so forth. But usually the sound of a word is unrelated to the meaning of the word. Admittedly, some animals exhibit these features. One example is prairie dogs. They'll tend to vocalise sounds to indicate that a predator or prey is nearby, and the sound they emit seems unrelated to the predator or prey. For example, if a hawk is nearby, they'll emit a sound but also dive into a hole to warn other prairie dogs. And if wolves are nearby, they might stand still and emit a different sound. In other words, other prairie dogs seem to also respond to these sounds, implying these animals understand the sounds and movements, even when they cannot sense the hawks, wolves, and so forth. Yet perhaps the prairie dogs have learned to respond to these sounds, but do not really understand these sounds represent hawks, wolves, and so forth. In other words, this skill might not actually reflect reference and displacement, but might instead reflect operant conditioning. Now, the second feature of language is called grammar. That is, humans can apply rules to derive meaning from words. To illustrate, we tend to unconsciously apply the rule, a subject affects an object. Now, you might not be aware that you apply this rule, but if you didn't apply this rule, you could not distinguish the sentence, the boy hit the ball, from the sentence, the ball hit the boy. Indeed, our language comprises an endless number of rules. Some rules indicate which sounds can be combined to form words. We can blend th and a to create the word the, but we cannot combine th and ch to create a word. Admittedly, some animals utilise some grammar. For example, baboons can actually learn to distinguish words from non-words. That is, after training or learning on which items are words or non-words, they can predict whether something like drannel, spelled D-R-A-N-L, is likely to be a non-word, whereas dap, spelled D-A-P, could be a word, at least in some languages. That is, baboons, like humans, can sort of learn the rules that seem to separate typical non-words from typical words. They learn that certain blends of letters are rare in words. Even sea lions are sensitive to the order in which the words appear. They could distinguish the phrase balance ball on nose from balance nose on ball. And this comparative indicates that they may learn some grammatical rules. However, the number of rules that animals can learn is relatively limited, at least compared to humans. The third feature of language emanates from this second feature of language. Specifically, using these rules, humans can produce and understand an infinite number of phrases called productivity. They can even generate new words. Here are some examples of fairly new words derived from blends of previous words. So can you guess these words? So the answers are cyborg, a combination of cyber and organism, spork, a combination of spoon and fork, infomercial, a combination of information and commercial, and jeggings, a combination of jeans and leggings. And animals can produce only a limited number of sounds. Admittedly, some animals can produce many sounds, including some new sounds. Mustache bats blend 33 basic sounds to form new composites. Now finally, in humans, language can be used in any situation or context. In contrast, for example, a humpback whale only emits sounds in specific circumstances, such as during mating or while feeding. And related to this rule is the notion that language evolved to facilitate communication in humans, and is not merely a byproduct of some other biological function. In contrast, in dogs, panting might imply they're hot and thirsty, but actually this panting didn't evolve to facilitate communication. Instead, this panting evolved to cool the body of dogs. So in short, the language of humans exhibits some unique features. For example, humans can refer to concepts they can't see or sense. They can utilise rules to produce and understand an infinite number of phrases and so forth. But how is this definition of language relevant to learning and development? Well, these features enable humans to learn and develop without classical conditioning, operant conditioning, or observational learning. That is, these features enable humans to learn and develop without actually experiencing or observing some events. So to illustrate, how do we learn to refrain from eating dirt? Well, we could apply operant conditioning. That is, we could eat dirt many times and then experience aversive consequences or punishments, such as illness or disapproval from parents. Or we could apply observational or social learning. That is, we could watch someone eat dirt and then watch them vomit. But unfortunately, these sources of learning elicit two problems. First, these sources of learning enable only gradual change, and hence learning is quite delayed. And second, these sources of learning can be dangerous. For example, even eating dirt once could damage our health irreparably. But fortunately, humans can use language to learn and develop, called rule-based learning. That is, somebody can say to us, if you eat dirt, you'll feel ill, or if you speed while driving, you'll be fined. Hence, we can learn the association between some act and the consequence immediately, and without actually having to experience or observe this act. We can thus learn rapidly and safely. Indeed, the features of language help us learn these rules. For example, suppose we could not refer to objects that we can't see or sense. Therefore, we couldn't actually learn rules about events that we hadn't experienced. Learning would be limited. Likewise, suppose we couldn't use grammar to produce and understand an endless number of phrases. Well, then we couldn't develop rules about new advances, such as the internet, and so forth. So language enables us to learn from rules effectively, and thus helps us learn rapidly and safely. You might therefore feel that other sources of learning, such as classical conditioning, operant conditioning, and observational learning, are unnecessary. Perhaps you did not need to waste time learning about classical conditioning, operant conditioning, and observational learning. But actually, rule-based learning is not sufficient. That is, we need the other sources of learning to flourish. So why do we need the other sources of learning to flourish? That is, what are the drawbacks of rule-based learning? Well, the key drawback is that rule-based learning actually generates inflexible behaviour. That is, when rule-based learning is applied, people might learn rapidly, but they can't adapt well to changing circumstances. So to illustrate why, suppose we applied operant conditioning or observational learning to learn to refrain from eating dirt. During these experiences, we would learn that eating dirt is more hazardous in some situations than other situations. For example, we might not be punished if we ate snow. We might not be punished if the dirt was only lettuce and so forth. So we would develop a more complex understanding of when we must avoid dirt and when dirt might not be as hazardous. We even might be willing to eat some dirt in specific circumstances. But now suppose we depended on language to learn to refrain from dirt. Perhaps a parent said, if you eat dirt, you'll be ill. Well, these rules are unlikely to communicate the nuances, such as eating dirt is not as hazardous when consuming lettuce. And so consequently, we're likely to shun dirt in all circumstances. Our behaviour might not be flexible enough. We might even develop obsessive compulsive disorder as we strive to avoid dirt, unaware that some dirt is not always dangerous.